Uh, Good afternoon, guys. We are talking about the Y parameter or the admittance parameter. Okay. So the numerical is that find find Y parameter for a network. Okay. So Y parameter is called the short circuit admittance parameter. Okay. Just recall these things. Uh, this is a network which can be represented in a two-port network. This is the input port and this is the output port. Okay, so the y1 dash I dash. Oh, so this is one dash and this is I1, and it is coming the I2 current, and this is V2 and this is V1. Okay, and this is the network. Okay, just like this. So we can represent this network by the admittance parameter, means short circuit admittance parameter, by the Y, that is I1 current is given by Y11 V1 plus Y12 and V2, and then in I2 is Y21 V1 plus Y22 V2. Okay, so in this matrix, if you go for this matrix, then we can find that is sorry, only I, this is Y, and this is V. So what is this? Y is called the admittance parameter. Okay, or it is called the admittance matrix, and it is Y11, Y12, and Y21 and Y22. So this is called the admittance parameter, and through this we can represent a network. So each element has a specific name. We can find out that is just recall this Y11, and it is the look, it is the input. Okay, and it is called driving point admittance, or it is called short circuit input admittance. So it is called driving, just write down driving driving point and driving point admittance, or it is called Y21. Sorry, not 21, another name is there, because this is the input, and this is making, whenever we make this port short, then we get this two parameter. When make this two port when make this port short, then we get this two parameter. Okay, so, all time you can see we have to make short any port, so that's why it is sorry, this is short, so that's why it is called the short circuit, and this is the input, that's why it is called the input admittance. So it is also called short short circuit short circuit input admittance. Okay, and next point is to y21. Look, y21, this parameter, it is also when v2, this portion is short, then we get it. So it has a specific name. It is the short circuited forward transfer admittance. Okay, and it is, this is also called the transfer admittance, all called the transfer admittance. Okay, and another four terms is there, y12. When y12 is required, then we have to short this this port, means a one dash should be short, and this is the open means this is voltage is applied. So then it is called, then y11 is called transfer admittance. Okay, it is the transfer admittance. It is the transfer admittance. It is transfer admittance at port 2 dash with port 1 dash open. Sorry, short. Okay, and it has a specific name. It has a specific name. It is called short circuit reverse transfer admittance. Short circuit reverse transfer admittance. Okay, then y22. Y22, it is called short circuit driving point admittance at the port 2 dash, and when 1 dash short circuited. At port 2 dash with port 1 dash short. It has it has a specific name. It is called short circuit output admittance. Okay, short circuit output admittance. Now we have to find out this y11, y21, y12, and y22. Okay, for this circuit. So whenever we go for this y11, y11, then we can get I1 by, that is V1, when that is V2, when V2 is 0, means short circuited. So circuit will be just like this. Circuit will be not the same. It should be changed. You can see the 4 ohm will be cut out because this portion is short. So we just make it open, and this A, this is A dash, this is 1, this is 2, and this is 2. So we here, if we looking for here, then we can get a equivalent resistance or impedance. Okay, so find out this. So z equivalent equal to 1 plus 2 parallel with parallel. So it is giving 1 plus 2 into 2 by 2 plus 2 equal to 1 plus 4 by 4, that is 1, that is also 1. So 1 plus 1, that is 2. So Z equivalent is the 2. Now we know that V1 equal to I1 Z equivalent. So I1 2, this is one formula. And another thing is, so we have to find out this. We have to find out this. Just put the value of V1 over here. So we Y11 is Y11 and is I1 by I1 2. So I1 cut out, so we get half, that is reverse of this ohm, so it is called mho. Okay, and we can find out similarly we can find out that is y21. So y21 is the I2 by v2 when v sorry, this is v1, I2 by V1 when V2 is short circuited. Okay, so we know that with the port B dash short circuited. So minus I2 equal to I1 into 2 by 4. Okay, so it is giving you I1 by 2, and therefore I2 is the V1 by 4. So Y21 we can put it, that is I2 by V1 equal to minus of 1 by 4 mho. Okay. Similarly, we can find out Y22 and Y12. Okay, is short circuited. So, the make this circuit. Okay. So A and A dash is short. So we have to find out I2 by V2 equal to 0. Okay, and V2 is I2 into Z equivalent. This Z equivalent impedance is whenever we are showing from this area. So we can see 1 and 2 is parallel, then again series, again parallel with this 4. So this is 1 parallel with 2, then it is series with this, then whatever it will be coming, it will be parallel with 4. That is the equivalent resistance, Z equivalent. Okay, so if you go for solve, guys, you can solve it, then you can get the value Z of equivalent, Z equivalent equal to 8 by 5 ohm. Okay, 8 by 5 ohm. Just solve it. Okay, this is one equation. And then if we put the value, more, this is 8 by 5 more, just it will be changed. If you put the value of this, then I2 is cut down, then 8 by 5 means it will be changed. Now I want to is, okay, so as E rest is short circuited, then I1 equal to 2 by 5 I2. Okay, so we can write it. I2 is the 5 by 8 V2 and minus I1 equal to 2 by 5, and this 5 by 8 V2 is the V2 by ultimately 4, because 5 cut out, this is 2 by 4. So this is the V2 by 4. Now we have to find out y12 equal to the I1 by V2 when V1 equal to short. So we have to put out, then we can find it, that is put the value of I1 and put the value of V2, then we can get, that is ultimately minus 1 by 4 more. You can see that is y21 equal to y12. Okay, y21, this is also 1 by minus 4, and in previous cases we also find out that is also 1 by minus 4. Sorry, minus 1 by 4, it is also minus 1 by 4. So this is the reciprocity. So, so the describing the equation term of admittance parameter. Okay, so we can write out I1 equal to 0.5 V1 minus 0.25 V2, and I2 is the minus 0.25 V1 plus 0.62 V2. Okay, so now we are talking, this is the numerical of Y parameter or admittance parameter. Now we are talking about the transmission parameter, that is ABCD parameter. Now we are talking about transmission parameter, or it is called ABCD parameter. So ABCD parameter are widely used in generally transmission line and the cascade network, etc. Okay, so you can write out ABCD parameter meters are widely used in transmission line theory. Okay, so what is ABCD parameter? ABCD parameter is V1 equal to A V2 minus B I2. Okay, because I is entering and I1 is C V2 minus D I2. Okay, this is the ABCD parameter. We can write down. Okay, this is the network. So this is the V1, you all know, this is +1, this is the -1, this is the +2, this is the -2, and here this is entering is the I1 and entering is the I2. This is the ABCD parameter. And if we go for the matrix format, then we can find out that is V1 I1 equal to A, B, C, D, and that is V2 minus I2. Okay, because minus I is connected with minus term, so that is -2. And this A, B, C, D is called the transmission matrix. This A, B, C, D called transmission matrix. Okay. And so for the given network, this ABCD parameter can be determined as below. With the port, when the port 22 is open, means this port is open. When 22 port is 22 dash 11 dash 22 dash is open, then I2 is 0, I2 is 0, and applying the voltage V1, you can write that with port 22 dash open, I